Okay, dear students, chemical kinetics. Chemical kinetics chapter is very important for objective examination, either NEET or JEE and CET examination. Compulsory one question guarantee for JEE mains and one or two questions guarantee for NEET and two questions guarantee for CET examination. At the same way, for board examination also, it is very important chemical kinetics chapter. It's very easy also, that chemical kinetics. Okay, so integrated rate equations for zero order, first order reactions, and zero order and first order reactions examples, half-life period, those are the very important, and factors affecting the rate of reaction. That concepts are very important, ma. Okay, chemical kinetics chapter, let's see. First one, listen first question. See in the first question what they gave. In the first question, they gave elementary reaction. 2A is converted into C. Okay, this is the elementary reaction. The concentration of A after 30 minutes at T is equals to 30 minutes. Concentration of A is equals to 0.01 molar. Mole per liter means 0.01 molar. If the rate constant, K value also they gave, K is equals to 2.5 into 10 to the power of minus 2 liter per mole second inverse. Okay, this is the rate constant value. Find the rate of the reaction at 30 minutes. Then for this reaction, the rate is equals to K into concentration of A whole square. Concentration of A whole square. So from the rate law or rate equation, the rate is directly proportional to concentration of reactant. The power is 2. For elementary reactions, the number of moles of reactant is equal to its order. Then the rate is equal to K into concentration of A whole square. Then the rate at 30 minutes is equal to K value. You write 2.5 into 10 to the power of minus 2, and concentration of reactant A is equals to 0.01 whole square. Not minus 2, sorry. K is equals to 2.5 into 10 to the power of minus 2 into concentration of A whole square, 0.01 whole square. 0.01 means 10 to the power of minus 2 is nothing but 2.5 into 10 to the power of minus 2 into 10 to the power of minus 2 whole square is nothing but 10 to the power of minus 4. Then the rate at 30 minutes is equals to 2.5 into 10 to the power of minus 6. 10 to the power of minus 6 mole per liter second inverse. Mole per liter second inverse. So the correct answer is 2.5 into 10 to the power of minus 6. Means second option is correct. Let's see the second question. The second question, they gave 2NH3 decomposition of ammonia in the presence of gold or molybdenum catalyst converted into N2 plus 3H2. Okay, the rate with respect to N2 is equals to 2 into 10 to the power of minus 3 minute inverse. The rate with respect to N2 after 20 minutes will be, see, it is an example for zero order reaction. It is example for zero order reaction. Zero order reactions. So zero order reactions rate is equals to K. Means the rate is constant. Rate is a constant. Means the rate does not changes with time. The rate does not changes with time. The rate does not changes with time. Therefore, the rate with respect to N2 after 30 minutes or after 20 minutes or 30 minutes or 20 minutes, whatever it the time they gave, it is constant only. That is equals to 2 into 10 to the power of minus 3 mole minute inverse. So the correct answer is the first one, because see here, that's why I said we have to remember the zero order reactions and first order reactions. Examples also we need to remember. Decomposition of ammonia is zero order reactions. Zero order reactions rate is independent with respect to time because the rate is constant. See, we know that zero order reactions rate is equals to K into concentration of reactant. Order is 0, r power 0 is nothing but 1, then the rate is equals to constant, rate is equals to K. That's why the rate does not changes with time. The rate with respect to all reactants and products does not changes with time, or rate of reaction does not changes with the time interval. That's why rate is constant, that is equals to 2.2 into 10 to the power of minus 3. Okay students, let's see the next question, third one. The third question, what they gave me, the specific rate of the reaction. Specific rate of the reaction is nothing but rate constant. K is equals to, K value how much they gave me? 1.5 into 10 to the power of minus 4. 10 to the power of minus 4 liter per mole second inverse. Liter per mole second inverse is the initial. If the reaction is commenced with 0.2 mole per liter of the reactants, means the concentration of reactant is 0.2 moles, the initial rate of the reaction, means what is the rate of the reaction they asked. So based on the units, it is liter per mole second inverse, means based on the units of K, based on the units of K, it is second order reaction. Second order reaction. Okay, means for rate constant for second order reaction is liter mole inverse second inverse. So according to that, order is equals to 2, means N is equals to 2. Okay, second order reaction. Then we have to find out the rate at 0.2 molar. Then therefore rate is equals to K into concentration of reactants whole square. Then K value they give. What is the K value? 1.5 into 10 to the power of minus 4. And R value, concentration, how much they gave? 0.2. 0.2 whole square. 0.2 whole square. Then is nothing but 1.5 into 10 to the power of minus 4 into 0.2 whole square is nothing but 4 into 10 to the power of minus 2. 4 into 10 to the power of minus 2. 1.5 into 4 is nothing but 6 into 10 to the power of minus 6. 6 into 10 to the power of minus 6 mole per liter second inverse. So what are the units for rate of reaction? Rate of reaction is nothing but change in the concentration with respect to time. That's why change in the concentration is nothing but mole per liter second inverse. Okay. See here, the main important thing is specific rate of reaction is nothing but rate constant. K value is equal to 1.5 into 10 to the power of minus 4 liter mole inverse second inverse they given. And the rate concentration of reactants is equal to 0.2 mole per liter they gave. So they're asked to find the rate of the reaction. Find the rate of the reaction they're asked. So for this case, first we have to find out whether the reaction is order. We need to find out according to the units of K. Then we are find out that order of the reaction is 2. Then the rate is directly proportional to concentration of reactant whole square. Then the rate is equals to K into R whole square. R value, concentration of reactant 0.2 gave. Then substituted that concentration of reactant and K value. Then the rate of reaction, how much we got? 6 into 10 to the power of minus 6 mole per liter second inverse we got. That is third option is correct. So next, let's see the fourth question. The fourth question, for a reaction, the reaction is process 2A is converted into products. Okay, the rate of reaction with respect to A. Rate of A at 10 seconds. At 10 seconds is equals to 2 into 10 to the power of minus 2 molar second inverse, means mole per liter second inverse. Okay, now already we know that with increasing time, rate of reaction decreases. Rate of reaction decreases. So now the rate at 5 seconds is more than 10 seconds, and rate at 15 seconds or at 15th second is less than 10 seconds. Okay, understand? So the rate of reaction decreases with increasing the time, means time interval increases, the rate of reaction decreases. Now the rate at 10 second or 10 time is equal to 10 seconds. At that case, rate of reactant with respect to A they given, but 5 seconds means the value should be more than 2 into 10 to the power of minus 2, and 15 second the value should be less than 2 into 10 to the power of minus 2. According to the options you have to check. The first option, okay, 5 seconds, this is at 5 seconds, it is more, but it is at 15 seconds, it should be less, it is also more. So both values are more, that's why this option we don't choose. Now let's see second option. The second option is the rate at 5 seconds 2.1 into 10 to the power of minus 2 is more than 2 into 10 to the power of minus 2, and the rate at 15 seconds it should be less, means 1.6 into 10 to the power of minus 2, it should be less than 2 into 10 to the power of minus 2. So the correct answer is 2. So according to the options only we need to check. The concept for solving this question is the rate of reaction decreases with increasing the time. If time interval is increases, the rate will be decreases. So 10 seconds at 10 second rate they gave. What happens at 5 seconds and 15 seconds they asked. 5 seconds the rate should be more than 10 seconds, and 15 seconds the rate should be less than 10 seconds. Like that pair we have to choose. Then the correct answer is second option. So the answer is second option. So according to the options only we have to solve this question. Now for this solving this question, the concept is rate of reaction decreases with increasing the time. Okay, let's see the fifth question. See how to solve this fifth question. Now they given one equation, that is 2N2O5 is converted into 4NO2 gas plus O2 gas. So for this reaction at T, time is equals to 10 minutes, the rate of reaction with respect to N2O2 and NO2 they're asked, N2O5 they're asked. So in any reaction, any chemical reaction, the rate of reaction is same with respect to all reactants and products. So with respect to all reactants, reactant means here N2O5 and products means NO2 and O2. So the rate is same. So for this case, the rate of reaction is same when it is here. See, observe that options. According to options, fourth is correct. Okay, fourth option is correct because all rates with respect to N2O5, NO2 and O2 is same gave 400, 400 and 400. So any chemical reaction, rate of reaction will be constant at particular time period, at constant time. So the rate of reaction with respect to all reactants and products is same at a particular time period at constant time. That's why according to that statement, the correct option is fourth one. Okay. Let's see the next sixth question. See in the sixth question, they given one equation that is hydrolysis of esters in basic medium. We know very well hydrolysis of esters in basic medium is second order reaction. The rate is depends on the concentration of ester and concentration of base. So the rate is equals to K into means. So for this case, rate is equals to R is equals to K into concentration of ester into concentration of base. Here base they gave sodium hydroxide. Now what they did initially its concentration of reactants ester and base is 1 units. If you are observed, then they are diluted with water. So it is, if water is 3 times of water is added, means diluted with water by 3 times, then total volume becomes 1 plus 3 is equals to 4 times. See, if volume is increased by 4 times, then concentration decreased by 4 times. So if after on dilution with water by 3 times, then the total volume increased by 4 times, then the concentration is decreased by 4 times. In that case, the rate is equals to R1 is equals to K into concentration of ester. How many times it is there? 1 by 4 times. And concentration of base NaOH also becomes 1 by 4 times. Now this 1 by 4 into 1 by 4 is nothing but 1 by 16 into K into concentration of ester into concentration of base. Then this K into concentration of ester we can write then R1 is equals to 1 by 16 into R. 1 by 16 into R means what happens the rate is decreased by, therefore rate decreased by 1 by 16th times. our rate becomes 1 by 16 times, means 16 times rate is decreasing. Rate is decreasing by 16 times or 1 by 16th times. Okay, so the correct answer is third one. Let's see the 17th question, sorry, 7th question. The concentration of reactants decreased from 0.2 molar to 0.05 molar in 5 minutes duration. Then the rate of reaction they are asked. See, we know that theoretically, what is the rate? Rate is nothing but change in the concentration. Change in concentration by time interval. Time interval. Time interval. So change in the concentration means 0.2 molar, it becomes 0.05, means 0.2 minus 0.05 by, see units, if you observe that they are given the time units for the rate is second inverse they given, we have minutes they gave, that is 5 minutes, 5 into 60 seconds. Then on solving this, 0.2 minus 0.05 is nothing but 0.15 by 5 into 60, then we'll get 0.0005 mole per liter second inverse, mole per liter second inverse. That is the correct answer. Let's see 8th question. 8th question. For the two reactions A is converted into B and C is converted into D, then Ka is equals to 10 to the power of 15 into e to the power of minus 2000 by T, and Kc is equals to 10 to the power of 14 into e to the power of minus 1000 by T. Okay, if Ka is equals to Kc is equals to K, then 10 to the power of 15 into e to the power of minus 2000 by T is equals to 10 to the power of 14 into e to the power of minus 1000 by T. Okay, then it is equals to 10 is equals to e to the power of 1000 by T, e to the power of 1000 by T. Okay, now apply both on log, then actually base E is present means ln 10 is equals to 1000 by T into ln E. This ln we need to convert into log, means we have to multiply it with 2.303. Log 10 is equals to 1000 by T into log E, base E is nothing but 1. So then log 10 value is 1, then T is equals to 1000 by 2.303. So the correct answer is fourth one, 1000 by 2.303. Let's see 9th question. 9th question, actually the schema in the question is wrong. They gave at time 10 minutes time the constant volume of O2 is 90 ml, and final volume of O2 formed in the reaction is not 100 ml, it is 1000 ml. Okay, final volume of O2. So this is decomposition of N2O5. Decomposition of N2O5 is first order reaction. First order reaction. Okay, so for first order reactions, rate is equals to K is equals to 2.303 by T into log final volume by initial volume of O2. In terms of volume, then it becomes actually initial concentration by final concentration of reactants we need to write. But when the completion of reaction O2 is formed 1000 ml, but at 10 minutes time this volume is only 90 ml. So that point we need to observe. According to that, for first order reactions in terms of volumes, the volume is formed, by the one of the product. In that case the formula becomes K is equals to 2.303 by T into log Vf by Vi. Now the K is equals to uh, 2.303. So units also in minute inverse they are asked. Minute inverse means according to that K units are minute inverse means it is N is equal to 1, first order reaction only. Then by 10 into log 1000 by 1000 ml by 90 ml. 1000 ml by 90 ml. Then K is equals to 2.303 by 10 into log 100 minus log 100 minus log 9. Okay, it's very clear. Now K is equals to 2.303 by 10 into log 100 is nothing but 2 minus log 9 is nothing but 0.954. 0.954 is nothing but 2.303 by 10 into 2 minus 0.94 is nothing but 1.046. 1.046 is approximately 1. We have to consider it is approximately this value we are considered as 1. Then this final value is equals to 0.2303. 0.2303 minute inverse. So the correct answer is second option. The correct answer is a second option. Okay, students, clear? So here whenever N2O5 on decomposed to produce NO2 and O2 gas, initially the O2 gas at 10 minutes time 90 ml is present, but after completion of the reaction that O2 gas becomes 1000 ml. So 1000 ml is that total volume formed by O2, that is Vf. But initially on 10 minutes time is going on, then how much volume of O2 is present, the reverse equation we need to take. Then here actually finally O2 is 1000 ml is present, that is we have to consider as initial. At 10 minutes time it is 0. 10 minutes time it is formed how much 90 ml is formed. 90 ml is formed. So then this value becomes 1 almost. Then 2.303 by 10 is equals to 0.2303 minute inverse. Okay, let's see 10th question. The 10th one, if doubling the concentration of reactants A increased by the rate is 2 times. For example, rate R is directly proportional to concentration of reactants, the power is N. Maybe you imagine that if the concentration of A is equals to 2A, then that rate is equals to, the rate is how many times it is increased? My rate is increased by 4 times, means it is the rate is equals to 4R is equals to 2a whole power n. This is equation 1, let it be equation 1. This is let it be equation 2. Now, if concentration of A is equals to 3 times, it is increased, then the rate becomes 9 times, means it is equals to 9r, then 9r is equals to 3a whole to the power of n. Then we have to find out the order of A. See, 1 by 2 or 2 by 1 you do, then 4 is equals to 2 power n. From this 2 square is equals to 2 power n, then n is equals to 2. Either from equation 1 and 3 you have to take 3 by 1 also you do, then 9 is equals to 3 power n, then 9 is nothing but 3 square is equals to 3 power n, then n is equals to 2. Therefore, rate is directly proportional to the square of concentration of A. Square of concentration of A means second option is correct, because the rate of the reaction here order is 2, means the rate of reactant is increased by twice, then the rate is increased by 4 times. If the rate of reaction is increased by 3 times, then the rate is increased by 9 times, means the n is equal to 2. N is equal to 2 means the rate of reaction is directly proportional to square of the concentration of A. Okay, let's see 11th question. The 11th question, what they gave me? So decomposition of or formation of, consider the system containing NO2 and SO2 in which NO2 is consumed in the following two parallel reactions. So the first one is the NO2 is converted into N2O4. This is K1. Then the rate for this case, the rate is equals to R1 is equals to K1 into concentration of NO2 whole square. Concentration of NO2 whole square. Now the second equation, NO2 plus SO2 is converted into NO plus SO3. Now for this reaction rate is equals to K2, then the rate is equals to R2 is equals to K2 into concentration of NO2 into concentration of SO2. Concentration of SO2. Now in that question what they are asked, in that question the rate of disappearance of NO2 will be, see in the two parallel reactions, in parallel reactions rate of disappearance of NO2 will be R1 plus R2. R1 plus R2 means K1 into concentration of NO2 whole square plus K2 into concentration of NO2 into concentration of SO2. So the correct answer is second option. The correct answer is a second option. Okay, understand? Let's see the next question. 12th one. It's very easy, ma. Consider a reaction. First given reaction you write 2A plus B is converted into products. Okay. When for this reaction rate R is equals to K into concentration of A, because the order is determined experimental only from the rate equation or rate law means what is the power on A, let it may be n, and B may be y, like that the rate expression or rate law we are deriving. Now let's see that statements when the concentration of B means concentration of B increased, B is equals to 2B, then the rate does not changes. Rate does not changes. Then what is that meaning? Y is equals to 0 means y is equals to 0 means the rate of reaction is independent on concentration of B. Therefore, rate is equals to K into A power N into B power 0 means it depends on only concentration of A. Alone concentration of B is double. If alone concentration of A is becomes 2A, then the rate is increased by 2 times. Then the rate is equals to 2R. The rate